Today we are going to cover section 12.2. We are going to multiply and divide rational expressions. Go and take the time to copy your essential question and copy down example number 1. We'll start once you are ready. So go and pause it. Excellent. So we are going to simplify the following expressions that have a multiplication or a division on example number 2. Now, whenever we have a rational expression, remember the word rational comes from the word ratio, which means a fraction. So in order to be able to multiply, we need to factor each of those polynomials completely, and then we're just going to cancel the factors. So let's start with the first one. I'm going to place a fraction bar times another fraction bar. And we're going to start with the first one, which is x squared minus 4. So therefore, you need to think, okay, how do I factor x squared minus 4? Do you remember the name of it, of this expression? They both are squares, and there's a minus in between. So it's called the difference of two squares. When it's a binomial and they both are squares, and there's a minus in between, we call that the difference of two squares because factoring is going to be much easier. Factors of x squared will be xx. Factors of 4 will be 2 and 2, and they have to be the same. One negative and one positive. Because if you multiply it out, x, if we distribute the x times x is x squared. X times 2 is 2x. Then if you distribute the negative 2 times x is negative 2x, so that cancels, and then you end up with negative 4. Denominator is a binomial, and we notice that we can factor out a 2, correct? So one number divides 2 and also divides 6, 2. And what's left behind? What do I need to multiply 2 to end up with 2x? X. What do I need to multiply 2 to end up with 6? Positive 3. So very similar to what we did last time. But now we are going to do it twice because we also need to be able to factor this trinomial. It's a trinomial, so we're going to use double parentheses. Factors of x squared will give us x and x. Factors of 3 will give us 3 and 1. That's a positive 3. So we know they need to have the same sign. But they need to add up to a positive 4x. So they both should be positives. If I double check to make sure that I end up with positive 4x, we multiply our outside numbers, our inside numbers, and we should end up with positive 4x. So x times 1 is 1x. 3 times x is positive 3x. If we add them, does it give us positive 4x? It does. Denominator. We have a binomial. So we need to make sure that we can take out the common factor first. Well, this does not have a number, so we cannot factor out a number. But they both have x's. This has 3 x's, and this one has 2. So how many can we take out? We can factor out 2 of them. So we can take out x squared. Remember, you can always take out the smallest x, the smallest number of x's. And what's left behind? What do I need to multiply x squared to end up with x to the third? X squared times 1 more x will give us x to the third. X squared multiplied by what will give us negative 2x squared minus 2. I don't need another x because that's x squared comes over here, and that's all I need. And I close it. And now I can see what cancels. So let's see, in this case, I can only cancel my factors. Same thing as before. So I can fact the x minus 2 and x plus 2 are multiplying each other. So that those can be canceled out. So therefore I can cancel my x minus 2 and x minus 2. What else can I cancel? my x plus 3 and x plus 3. So therefore, on the numerator, I have x plus 2 times x, because they're still multiplying, will be x plus 2, x plus 1. My denominator, I have 2x squared. And they're multiplying, so I'm just going to multiply them together. It gives me 2x squared. Remember that I cannot cancel this 2 because of this plus. X plus 2 is together. It's a whole factor. So this will be my final answer. And you guys will be using this skills in Algebra 2, in pre-calculus, and also in calculus. Letter B. We're just going to go through the same process. I'm going to factor each one. So let's start with the first one. That's a trinomial. So I place my fraction bar times my fraction bar. So it's a trinomial. I'm going to use my double parentheses to factor this out. Factors of 5x squared will give me 5x and x. Factors of 12, I can use 3 times 4. What else? 2 times 6 or 1 times 12. Only one of those combinations is going to work. When I multiply my outside numbers and my inside numbers, they need to end up with negative 23x. So which one should I use? Well, I need to end up with 23, right? So if I place my 4 here, that gives me 20, and my 3 here gives me 23. That's 20, and 3 is 23. Now this is a positive 12, so they need to have the same sign, both positives or both negatives. They need to add up to a negative 23, so they both should be negatives. X squared minus 16. I'm going to use double parentheses because what type of binomial is this? Correct. It's a difference of two squares. 1, 2. Factors of x squared will give me x and x. Factors of 16, they both have to be the same, so be 4 and 4. 1 negative and 1 positive. Remember, that's the difference of two squares. The factors are exactly the same except for 1 negative and 1 positive. I'm going to continue with my next polynomial. It's a binomial. I know it's not the difference of two squares because there's a plus in between. But I notice I can factor out the common term. So what can I factor out? One number divides 3 and 12. I can do 3. 3 divides 3 and 3 divides 12. How many x's can I take out? This one has 2 and this one has 1. So I can take out 1. And what's left behind? 3x multiplied by what gives me 3x squared? 3x times x. 3x multiplied by what gives me positive 12x, gives me positive 4. And that works, right? Now the last one is a 5x minus 3. So what can I factor out? I know it's not the difference of two squares because that's not a square. That's not a square, and that's not a square. There's a difference, but none of those two are squares. Is there a number that divides 5 and 3? No. So it stays exactly the same. 5x minus 3. So remember, you don't always have to factor something out. You're not able to do so every single time. So what can I cancel out? Let's see, my x minus 4 is gone. 4 is gone. So the only thing that's left is a 3x. There's nothing on the denominator, so we can place a 1 underneath, but we don't need it if it's on the denominator, so therefore our answer is only 3x. So the main concept of this is that if you're comfortable factoring, this should be an easy process. Example number 2, then we'll do example number 3, and then we'll be done for the notes for today. Go and copy it down, and we'll start once you are ready. In this case, we have a division. Now, do you guys remember what to do when you guys divide fractions? For example, if I have 1/2 divided by um, 3/2. To divide, we are going to change it to the first fraction stays the same. We're going to change the division to multiplication, and we're going to take the reciprocal of both fractions. So that gives me 2 over 3. And we can multiply across if you want. 1 times 2 is 2. 2 times 3 is 6. But we also learned that we can actually cancel out the factors. So therefore my answer will be 1/3. And that's what we're doing here. If you have a division, we are going to change the division to multiplication. Our first fraction will stay exactly the same. Our second fraction, we are going to take the reciprocal. So therefore my x squared plus 3x will now go on the denominator. And my x squared plus x minus 6 is going to go on the numerator. And now we have a problem exactly the same that we had before. So we are going to change to multiplication. That's a multiplication. And I want to factor each one. So therefore my 3x, what can I do with a 3x? Nothing. So it's just going to stay in as is 3 times x. How can I factor my x squared minus 4? What is that called? That is called the difference of two squares, correct. So therefore, I can use double parentheses to factor that out. Factors of x squared will give me x and x. Factors of 4 will give me 2 and 2, 1 negative and 1 positive. I'm going to factor out this trinomial. 3 terms, so therefore I'm going to use double parentheses. Factors of x squared will give me x and x. Factors of 6 can be 3 times 2, 6 and 1. That's a negative 6, so they need to have different signs. One negative, one positive. If I multiply my outside numbers and my inside numbers, it should add up to a positive x. So which one should I use? Correct, I should use 3 and 2. Which one should be positive? Because I need a positive 1x. Should be my positive 3 and my negative 2. And that works, right? That gives me a negative 2x. That gives me a positive 3x. If I add it together, it gives me a positive 1x, and that is what I need. My denominator, what can I factor out? 2 terms, I can factor well, this one doesn't have a number, so I cannot factor a number out. I can factor an x. And what's left behind? What do I need to multiply x to end up with x squared? X. What do I need to multiply x to end up with positive 3x will be positive 3. And now I can cancel. My x minus 2 cancels out. My x plus 3 cancels out. And in this case, the question is, can I cancel those two x's? Well, in this case, there's no plus or minus. This is multiplying. And the 3 and the x are multiplying as well. There's no pluses or minuses. So therefore, I can also cancel out my x. The only thing that we have left is a 3 and x plus 2. And you can place the x plus 2 in parentheses, but in this case, you don't need to. Letter B. So first, we are going to change my division to a multiplication. And I'm going to take the reciprocal of only the second fraction. Your first fraction will stay exactly the same. I'm going to make sure that my numerator goes in the denominator now. And that is because I changed my division to a multiplication. If I want to change my division to multiplication, I need to change the second fraction to the reciprocal. I change my division to multiplication, I change my second fraction to the reciprocal. And my 3x minus 15 goes on the numerator. And now you basically just be the same process that we learned last time. We're going to factor, 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 and see what cancels. Try and see what you get, and then we can compare our answers. Go and pause it. Excellent. So in this case, let's start with the first one. 2x squared minus 4x. Now, if the x squared was 9 here and the x was in here, that'll be the difference of two squares. In this case, 2 is 9 squared, and then we have an extra x in here. So that is not the difference of two squares, but we can take a common factor. What can I factor out? One number divides 2 and 4? 2. Do they both have an x? Yes, I can take out 1x. What's left behind? What do I need to multiply 2x to end up with 2x squared? 2x times x. What do I need to multiply 2x to end up with negative 4x? Will be minus 2. Denominator. X squared minus 25. What can I factor out? Well, that one's called, what is this called? They're both squares and there's a minus in between. It's called the difference of two squares. Factors of x squared will give me x and x. Factors of 25 will give me 5 and 5. One negative and one positive. So you should be able to recognize your difference of two squares when they both are squares and there's a minus in between. Now the next binomial, 3x minus 15, what can I factor out? I can factor a 3 out. And what's left behind? Can I take out an x? No, because the 15 does not have an x, so I cannot take out an x. Right? So what's left behind? 3 times x will give you 3x. 3 times negative 5 will give you negative 15. Denominator, we have a trinomial, so we can use the double parenthesis. Factors of x squared will give me x and x. Factors of 2 will give me 2 and 1. That's a positive 2. They need to have the same signs. Both positives, both negatives. But they need to add to a negative 3, so they both should be negatives. If I multiply my outside numbers, I should end up with negative 3x. That gives me negative 1, and negative 2 is negative 3x, which is what I need. And now I can take out my factor. I can cancel my factors. My x minus 2 is gone. My x minus 5 is gone. And that's it. So therefore I can just multiply what's left, 2x and 3. I can place 2x times 3, but that will be 6x over. I have a x plus 5. I'm not placing in parentheses because I have another factor here, which is x minus 1. You do not need to multiply your denominator again, even though sometimes on your SATs you will see it multiplied. But at that point you should be able to recognize your answer. And the last example for today. So it's just a combination of example 1 and 2. And notice that this one's already a factor for you, and that's sometimes the case. There's a step that's already done for you. Go and pause it, copy it down, and then we can continue once you're ready. Excellent. So let's start. Now the first thing that you should notice is that you have a division that you need to change to multiplication. The first fraction will stay exactly the same. The second fraction, we're going to take the reciprocal. So therefore 2x squared goes on the denominator now. And this is already a factor for you. So that will save us a step. So do me a huge favor, go ahead and finish it up. B, A, and see what you get. And then we'll continue with letter B together. Go and pause it. So let's start with the first polynomial. It's a binomial. We know it's not the difference of two squares because 9 is a square, but that 2 is 9 squared, and then we have an extra x here. So we can take out a common factor. What can I factor out? Is there a number that divides 2 and 9? No. Do they both have an x? Yes, so I can take out an x. And what's left behind? What do I need to multiply x to end up with 2x squared? X times 2x. What do I need to multiply x to end up with negative 9x? Negative 9. Denominator. It's a binomial, but I know that's not a difference of two squares because there's no difference in between. So what can I factor out? Is there a number that divides 2 and 6? Yes, I can factor a 2 out. Can I take out an x? No, because the 6 does not have an x. So therefore, what's left behind? 2 multiplied by what gives you 2x? 2 times x, and 2 multiplied by positive 3. This is already done for you. 2x plus 5, x plus 3. I want to factor this out, double parentheses. So let's see, this is already done. Makes it a little easier to see what's left to do. What do we need to move? What are the factors of 2x squared? Will be 2x times x. What are the factors of negative 10? 2 times 5, 10 and 1. I need to end up with a negative 1x. So which one should I use? So I should use my 2 here because that will give me 4, and my 5 here because that gives me 5. If I subtract them, it's going to give me 1. I need to end up with negative 1. So which one should be a negative? Correct. The negative 5 and the positive 2. Because if I multiply that out, it gives me a positive 4 minus 5 is the negative 1x that I need. And now I can just cancel. Let's see, my x plus 3 is gone. And oh, I've made a mistake. Do you guys see the mistake? That should be the positive. So therefore that's a positive and that's a negative. Let's fix that. You probably cut that before I did. Correct? Because that's a positive. So it gives me negative 4 plus 5x is positive 1x. So therefore my 2x plus 5 is also gone. So what do we have left behind? We have a x multiplied by 2x minus 9. You don't need to multiply it out. You can leave it in factor form. You have a 2 and you have an x minus 2. So we can leave it like this. Remember that 2's cannot be cancelled because of this minus in between. That minus belongs to the 2x or to the 9, but this is an entire factor. You cannot separate. This is an entire factor, so you cannot separate it. If those two were both x's, then I can cancel those two x's. Those two will be, but in this case, they're not. So that will be your final answer. X multiplied by 2x minus 9 over 2 multiplied by x minus 2. And the last problem for today, we have a multiplication. So we can just factor, 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 and cancel, 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 cancel. So what is the first binomial called? Correct. That's called the difference of two squares. 1, 2. Factors of x squared, x and x. Factors of 9, 3 and 3. 1 negative and 1 positive. Denominator. It's a binomial, but it's not a difference of two squares. There's no difference in between. But what can I factor out? One number divides 5 and 15. 5. Do they both have an x? Yes. How many x's can I take out? This one has 3, this one has 2, so I can take out 2 of them. And what's left behind? 5x squared multiplied by what gives me 5x to the third? 5x squared times x. 5x squared multiplied by what gives me 15x squared plus 3. The denominator is already a factor, so therefore I can just leave it as this, which is 2x plus 5, x minus 3. I'm going to factor this trinomial. Factors of 2x squared will give me 2x and x. Factors of 5, 1 and 5 or 5 and 1? 5, 1. Because that will give me 10. that'll give me 1. I need 9, positive 9. They need to have different signs, so that'll be a positive 5 because that gives me positive 10 minus 1 is positive 9 that I need. So therefore that is already done. So I can cancel my x minus 3 is gone. My x plus 3 is gone. And that's it. So therefore my final answer is 2x minus 1 multiplied by x plus 5 over 5x squared multiplied by 2x plus 5. So notice that you don't always get nice answers as those. Sometimes you guys get more complex answers that will still be correct. And remember, you cannot cancel those two 5's because this 5 it's attached to the x as a factor. If there was a 5 over here, then you'll be able to cancel those two 5's. But this is your final answer. Email me if you have any questions. Have a great day, and I'll see you guys next time.